And then as far as atoms go, isotopes are going to be where we see that number of neutrons really being important. One of our common examples is going to be carbon. So if I look at my carbon atom, got my 6 up here, got my 12.01 here. This 6 tells me, if you remember from a previous video, this tells me how many protons I have. This tells me how many electrons I have. So I have 6 protons, I have 6 electrons. Now let's look at how we determined this atomic mass number and what our neutrons had to do with that. In nature, we have carbon 12, C12, we have carbon 13, and we have carbon 14. And what that means is for each of these, I'm going to move some of this out of the way, for each of these isotopes, we have, so carbon, if you remember, it's always, our number of protons never changes. So I have 6 protons, I have 6 electrons, and in this case, because my 12 minus my 6 is going to also be 6, I also have 6 neutrons. But what we're going to see change here is my protons stay the same for carbon 13 because they never change. My electrons are going to stay the same as well. And then 13 minus 6 is going to give me 7. So I have 7 neutrons. And this is because when we talk about this 12, this 13, this 14, we're talking kind of about the mass or the weight of this carbon in nature. And electrons are always in that cloud. They're very small. They really don't contribute to the weight very much. So the weight of an atom, or the mass of the atom to be more correct, is going to be heavily based on our protons and our neutrons. So this 6 plus this 7 gives us our 13. Then for carbon 14, we're going to have 6 protons again. We're going to have 6 electrons. And we are going to have 8 neutrons. Now let's look at something. When we have this weight, or this mass on the periodic table that is our atomic mass, we get that by averaging what we're finding in nature and looking at the percentages of everything. So if we see that this is very close to 12, like, if we were doing our rounding rules, we would round this down to 12. So that tells me, just looking at this, that we have a very high percentage of carbon 12 is what we find in nature, very high percentage. And then we're going to have very low percentages of our carbon 13 and 14. And so we take all that into account when we do our averaging, but that is why we have this number with some decimal places, because it's not, we don't just go out in nature and find an element and it's only one type of the element, typically, and then call it a day and have this round number on the periodic table. No, we find different isotopes of the element, and those different numbers of neutrons affect our overall mass, and once we average that, we have our atomic mass.